we can go to the R2 router. So before that we have to clear the screen. Okay, so router EHRP autonomous system number 500 and direct connected network of R2 router is 172.30.200.0. next direct connected network is 200.200.200.0. no auto summary exit. Okay, so now EHRP routing protocol is configured on ISP 1, R1 and R2, so the neighbor relationship will be formed. Okay, next we can go to the R1 router fast Ethernet 0/0 interface and R2 router fast Ethernet 0/0 interface to configure gateway load balancing protocol. So and virtual IP address here we are using is 172.30.200.2. so this virtual IP address can be assigned to the PC1, PC2 and PC3 for default gateway. So here we are configuring virtual IP address, means we no need to change any default gateway to PC1 and PC2 and PC3. even though if R1 router goes down, it automatically takes over R2 router, so the PC1 and PC2 PC3 can continuously ping to ISP. if one default gateway goes down, another default gateway can takes up. Okay, so now we can go to the R1 router fast Ethernet 0/0 interface to configure gateway load balancing protocol. So just clear the screen. Okay, so go to that interface global mode and go to that particular interface fast Ethernet 0/0. Okay, now the syntax for creating GLBP gateway load balancing protocol is just GLBP space we have to given the group number. So here the group number is 0 to 1023. so here we have to given any number we have to given. So here I will give the group number as 500. 500. next IP is an keyword. next what virtual IP we can assign as a default gateway. so here the virtual IP is 172.30.200.200. so 172.30.200.200 enter. now the GLBP is created in R1 router. Here in GLBP there is no preemption by default. in HSRP and GLBP by default preemption is disabled. only in VRRP only the preemption is enabled, and GLBP is a Cisco proprietary protocol. it only supports in Cisco device, other device it cannot be supported. Okay, next GLBP again we have to given the group number is 500 space preemption to enable the preemption. next GLBP. so by default once you are configured GLBP means by default all the router have the priority value is 100. so in R1 router also have the priority value 100. we can check do show GLBP. So here we can see the priority value is by default 100. so here I will change the priority value into 200. so GLBP and given the group number. next priority and priority value, here I will given 200 enter. next I will give the password for security purpose. so GLBP again we have to given the group number and authentication. next MD5, here text and MD5. text is a plain text and MD5 is an hashing, so text is not secure, so I will go with MD5. and here we have to given keychain and key string. Keychain means the group of keys and key string means only particular key. so here I will give the key string, that is particular key. so the key is Gautam, enter. Okay, so now exit. Okay, so now the GLBP is configured on R1 router. so before that you have to clear the screen. next we can go to the R2 router. Okay, so interface fast Ethernet 0/0. so the syntax for creating GLBP is GLBP gateway load balancing protocol space. here we have to given the group number. the group number is 0 to 1023. so here I will given the 500 and IP is an keyword. next what is the virtual IP to assign as a default gateway is 172.30.200.200 enter. next GLBP 500 and preemption. By default preemption is disabled in GLBP. Next, GLBP 500 and authentication MD5 and key string Gautam. So same keyword here also we have to given, then only it will communicate. Enter. Okay, so now GLBP is configured on R2 router and R3 router. So depends upon the priority value, one router can takes place as an AVG, that is active virtual gateway, and another router is an AVF, active virtual forwarder. So here the priority value for R1 and R2. In R1 I will assign the priority as 200, and in R2 the priority value is 100 by default. So which priority value is highest? R1. So now R1 router is act as an AVG, that is active virtual gateway, and R2 router can act as an AVF. So both R1 and R2 can act as an AVF. AVF is an active virtual forwarder. So R1 router act as an AVG and AVF, and R2 router only act as an AVF. So the PC1 and PC2 and PC3 can request the ARP request for virtual IP address, that is default gateway. So that time R1 router can reply to the PC1, PC2 and PC3 because AVG router only responds to the ARP request. AVF router cannot respond to the ARP request. And in GLBP, each router, that is each active virtual forwarder, have unique MAC address. Okay, we can check. So go to the R2 router, show GLBP brief. Here we can see this first one indicates the AVG, that is active virtual gateway, and second one and third one indicates the AVF. That means R1 router can act as an AVG and AVF, that means active virtual forwarder and active virtual gateway, and R2 router can act only AVF, that is active virtual forwarder.